Hi everyone, welcome back to Simple Gyan. Today, we're going to explore two fascinating properties of liquids, specific gravity and viscosity. You might have heard these terms in labs, industries, or even when checking engine oil, but what do they actually mean? Stay with me till the end, and you'll understand not just the theory, but also real-life applications that make these concepts super important for engineers and students alike. Let's start with specific gravity, also called relative density. It simply compares how heavy a liquid is compared to water. The formula is specific gravity equals density of the liquid divided by density of water. If the specific gravity of oil is 0.8, that means oil is lighter than water. That's why it floats. When SG is greater than 1, the liquid is heavier than water, like mercury. When SG is less than 1, the liquid is lighter, like petrol or alcohol. And because it's a ratio, specific gravity has no unit. Let's see a few examples. Petrol has a specific gravity of about 0.74. It floats on water. Milk is around 1.03, slightly heavier than water. Mercury has a huge specific gravity of 13.6. That's why it's used in thermometers and barometers. Even seawater has a slightly higher SG, about 1.025, because of dissolved salts. Specific gravity is also used in testing battery electrolyte health or checking purity of milk. Now let's talk about viscosity, one of the most important fluid properties. Viscosity means a liquid's resistance to flow, or simply, how thick or sticky it is. Water flows easily, meaning low viscosity. Honey flows slowly, meaning high viscosity. Technically, viscosity measures the internal friction between layers of fluid moving at different speeds. The SI unit is Pascal second, written as pi-s. When we talk about how fast a fluid moves under gravity, we use kinematic viscosity, measured in Stokes or square meters per second. Here's a real-life way to understand viscosity. Pour water and oil down a slope. Water rushes down quickly, while oil takes its time. That's viscosity in action. In engines, viscosity plays a key role. Cold oil is thick, meaning high viscosity, which makes starting harder. As it heats up, viscosity decreases and the oil flows smoothly for lubrication. That's why engine oils are graded like SAE 10W40. The 10W shows winter viscosity, and 40 shows the viscosity at high temperature. Let's see what affects viscosity. Number 1. Temperature. When temperature increases, viscosity decreases. That's why hot honey flows faster than cold honey. Number 2. Pressure. When pressure increases, viscosity slightly increases, though the effect is small. Number 3. Composition. Different liquids have different molecular structures. For example, glycerin is thicker than water because of stronger molecular bonding. In short, viscosity is all about the stickiness between molecules. So, how do we measure these properties? For specific gravity, we use instruments like hydrometer, pycnometer, and specific gravity bottle. For viscosity, we use instruments like Ostwald capillary viscometer, redwood viscometer, and Sable viscometer. In the redwood viscometer, for example, a fixed volume of oil flows through an orifice, and the time it takes gives its viscosity. Where do we use these properties? In the petroleum industry, viscosity helps grade lubricating oils. In the food industry, it controls texture of sauces and syrups. In civil and mechanical engineering, it's vital for designing pumps and hydraulic systems. In aviation and marine sectors, fuel density and viscosity ensure safe engine operation. Even in your car, specific gravity checks the battery's health, and viscosity ensures smooth engine performance. So let's wrap it up. Specific gravity tells us how heavy a liquid is compared to water. Viscosity tells us how easily it flows. Both are simple yet powerful concepts that drive entire industries, from vehicles to food processing. If you found this video helpful, don't forget to like, share, and subscribe to Simple Gyan for more easy-to-understand engineering videos. Thanks for watching, and remember, keep learning simply.